Okay, now let's start building another circuit, which is a parallel circuit. Okay, for this demonstration, I will use uh, the same simulation over here, since we already have power supply there, so you don't have to change your simulation, because we still have big area over here that can be used to develop our parallel circuits. Okay, just remember, this point over here is not connected. Even this is, for example, this is column 20, and this is column 20, but this column 20 does not connected with this one, because it's separate with this separator over here at the center. So that's why you can build some other circuit over here if you want. So in this example, I show you how to build a parallel circuit inside this area. So again, we need a two resistance, 1 kilo ohm. So I just take this one, I just Control C and Control V to take the device there. Then what I do, I choose to connect over here, which is this terminal is connected at row number 15, and let me shift it to the center, so we have a lot of space there. Okay, so it connected with row number 18. So if you refer to this schematic, okay, row number 18 here should be this one, because it connected with your first R, which is R1. Now we want to connect this row number 18 with your positive terminal of power supply. So where is the positive terminal of your power supply? Is this line. Okay, then I just take one jumper, connect with this row number 18 there. After that, if you go back to the circuit, row number 18 also connected with R2, the first terminal of the first lead of your R2 there. So then you can have your R2. Again, you just click this resistor, Control C and Control V, you get your R2. Then you just can't put here, because that point is your row 18, which is referred to, if you refer to this one, this is your column 18, and the column 18 connected with positive terminal of your power supply, as well as one terminal R1 and one terminal R2. So row 18, this is your 18 connected with the positive terminal of power supply, and one terminal of your R1, and one terminal of your R2. And then after that, you can see that the other terminal of your R1 and R2 will connected to the ground, as well as, in other words, connected with your negative terminal of your power supply. So this is the other terminal of R1, this is another terminal of your R2. So what you can do, you can connect this point to another point. Just drag that wires into, let's say, row 27 or column 27. Then this point also you have a wire connect to column 27. Now this column 27 is represent this point over here. Okay, just ignore this drawing first. Okay, I will discuss later. This is one I will discuss later. Okay, this is the point of your row 27. Now what is missing there? Row 27 also is connected with your ground or negative terminal of your power supply. So that's why then at this row or column 27 over here, you must have a one jumper where it's connected with that point with your negative terminal of your power supply. So then you already finish develop the circuit. If you run the simulation, of course it's work, but we don't know whether it's work yet unless we put the multimeter to see the result. Okay, so you can see that. So for example, now during the calculation we know that your I2 is equal to 5 milliampere. Okay, so in order to do that, you must put a multimeter. That's why I draw the green colors there. Actually that is where the location you must put your multimeter. It can be here or here to measure the current across this line. Okay, another thing you need to remember, once you put the things here, this wire must be disconnected, otherwise you cannot see the values there, because once you put the multimeter here, the point over here must be connected with the positive terminal of your multimeter, while this point over here must be connected with negative terminal of your multimeter. So it's not connected together like the obvious circuit, because the obvious circuit or the normal circuit, it just a connection. The connection is there's no terminals there, meaning that this point over here just cross over here by one wire. But if you want to measure the current across here, you must cut that connection. This part connect to the positive part, this part connected to the negative part of your multimeter. So that's why in your simulation also you must do that. Okay, so if I want to measure I2, then I can measure, this is my this is my R2. Okay, this is my R1, this is my R2. So the current flow in this line, okay, from this line into this line, that is I2, our I2. So how to measure that? So one way you can see these wires. You must disconnect this wire, but you must put the positive your positive terminal of your multimeter at this point, and you must put a negative terminal of your multimeter at this point. But which it's also mean that you are replacing this wire with your multimeter. Okay, so that is how you disconnect the connection between this point and this point. Because you want to measure the current across here, then you need to cut this wire, and the half of the wire going to that positive, this half of the wire is going to negative terminal. So one way you can do is that you just delete this one, and then this point going into your positive. Okay, and then this point going to your negative. Okay, if you simulate the circuit, okay, if you simulate the circuit, you just click the simulation, then you click the A over here. Don't use V. You must click A. Then you can see that it's a 5 millivolt. So then it's proof that this circuit is correct, because once you measure the current across this R2 here to measure the I2, then the value is 5 milliampere, which is similar to what you have to if you are using the hand calculation over here. So I hope by having that guidance you can use this TinkerCAD to simulate all circuits inside your lab sheet. And thank you.